All right, this is going on page 79 when we're done. And we're going to put the calculators down for a minute because we got some writing and talking to do before we push buttons. So the first thing we're going to do is we're going to find side links. This is totally just a review from geometry. This is exactly what you did in geometry, so we're not going to spend tons of time on it, but we do need to review it and be able to do it. So tell me, what is your little acronym for knowing how to set up your trig functions? SOHCAHTOA, right? And if you got to spell it right or it doesn't do you any good. So SOHCAHTOA, right? SOHCAHTOA. So I am finding, I need to find x, the length of that side. The length of that side. Is number one a question I could use Pythagorean theorem for? No. Okay, because sometimes there's more than one way to work a question, right? I can't because I only know one side. I'd have to know at least two. And it's not a special right triangle, so I can't use special right triangles. That's when I go, okay, now I have to use trig. And so everything is based off of the acute angle we're working with, which is 32. All right, across from 32 is 11, which is my opposite side. What is x? The hypotenuse. Okay, I'm not going to label the adjacent side just because I don't need it and I don't want it to confuse me. What you could do, because I do find, and y'all are all individual people, I do highly suggest, no matter how smart you think you are and how easy you think it is, to at least put the O and the H, because you don't want to make a mistake on an easy question, right? But if some people don't get if they just do two, they don't always get them in the right spot. It helps if you do all three to make sure it makes sense if you do it in the same order. So let's say I did say, all right, this is the opposite, this is the adjacent, this is the hypotenuse. Then I evaluate what I have and say, all right, well, if I need x and I have 11, I'm not using 8. Then after I do it, I'm going to mark it out so I don't do something weird then. Makes sense? So you don't have to. It's up to you. You do what works for you. Okay, just trying to give you some options. All right, so then I usually have students, not so much in pre-cal, but especially when I taught geometry, would say, I get all this, I can do, but how do you know which trig function to use? Well, we're down to opposite and hypotenuse. We use SOHCAHTOA. Which one uses opposite and hypotenuse? Sine. So you always take sine, cosine, or tangent of an angle. So I'm going to take the sine of the angle, which is 32, equals the opposite, which is 11, over the hypotenuse, which is x. So let's talk about what we just wrote. The sine of 32 is some value that the calculator is going to give me. I don't care what it is right now, and I'm not pushing any buttons right now. But it's a value. This is stuck together. Sine is an operation on 32. This is some value equals another value divided by x. Okay, just keep that in mind. I need to get x by itself. Does it make sense to multiply both sides by 11? No. I would multiply both sides by what? X, because it's in the denominator. So I'm going to have x times the sine of 32 equals 11. Now I need to get x by itself. X is being multiplied by the sine of 32, which is a value. So to get it by itself, I just divide both sides by the sine of 32, and I get x equals 11 divided by the sine of 32. Don't push buttons yet, because I want to show you something else. There are times that you have multiple things in the numerator or denominator, and that causes you on some calculators to have to use a lot of parentheses, right? To make sure that it's in the numerator or denominator. So yes, we could use the division key here, but instead we're going to type it in pretty much just like it looks right here. So if you look at your calculator, on the far left, under the calc button, you see the little button that looks like a fraction? Push that button, it pops a fraction up, you type 11 in the numerator, use the big button to arrow down, and then type in the sine of 32. You do have to close the parentheses though. Anytime you're using a fraction, it opens those, whether you want it to or not. You have to close it or you'll get an error. And then that way you can make sure that you have it all typed in like you intended. Okay? It's just, to me, that's a very helpful tool on here as well. So then we hit equals, and we have to be correct to 3 decimal places. So x equals 20.75 what? 8. And if we had units, which we don't, we would need to make sure we had units on there, but we don't have them, so it's fine. Okay. So y'all already see how amazing these calculators are? Yes, see? I probably should call them and tell them I need a cut of the money that I make them. All right. Okay, so let's look at number 2. I've got my angle. This is my opposite side. This is the hypotenuse, so I can think it, but I'm not going to write it. And then I have the adjacent. So what uses opposite and adjacent? Tangent, good. So we always take the tangent of an angle. So the tangent of 75 equals the opposite, which is x, over the adjacent, which is 21. Same process. I need to get rid of the fraction. I multiply by the denominator. So I get 21 times the tangent of 75 equals x. And then you just type that in just like you see it. You get a weird answer? Kind of, yeah. All right, well, that's because 75 is kind of a special angle also, because it's 60 plus half of 60, right? And so we can get an exact value, but we don't want an exact value here. It says to the nearest thousandth, right? So what do? SD. I think that means standard to decimal. I'm not sure what the S and the D stand for, but it doesn't matter. That's the button you push. And then we get that x equals 78.373. What questions do you have? Anything? Is it all coming back to you? Because you probably did this, you should have done this like a lot in geometry. All right, so if you don't have any questions, you do number 3 and stop. So make sure that you actually do it. You have to write some stuff down. You can't just look at it and type stuff in the calculator, because even when you have calculator questions, you still have to have some process, like what did you do in the calculator? Even if it's not, even if all you type in, if all you write down, I mean, I suggest that you probably should write this down, but even if this is all you write down, you have to write down the first step and you have to write down the answer. Okay, don't just have the answer, otherwise where the heck did it come from? Okay. What questions we got? Anything? Okay, good. All right, no questions? All right, then you do number 4. What she said makes sense. Yeah. Check yourself with me. And then I want you to look at numbers 1 and 4. So 1 and 4 are basically the same type of problem. 2 and 3 are the same type of problem. But notice in 1 and 4, when we set it up, the variable was in the denominator. So both times we multiplied both sides by the denominator, which is the variable. Then we divided by the trig function to get a fraction that has a side over the trig function, right? And that's if you end up with this setup, because like basically you're going to, there's only 2 sides that you're going to use. So it's either the variables in the numerator or it's in the denominator, right? So if it's in the denominator, you're still going to have a fraction in the end. But, and I'm only saying this because I usually get this question at some point, so I want to clarify it for everybody. Not all of you need to do this, but you know yourself. You know whether or not you should skip steps because you don't want to make up math. But if you have this situation, you can see that these two pieces just switch places, and you can kind of go from here to here. Does that make sense? And that's totally fine as far as showing work and whatnot. Just if that doesn't really make sense to you, don't do it. Do all the work. Okay? You got to know where you are in your process. Okay. We good? Any questions? Okay, so let's talk about angles, because that was us finding sides. So now we're going to talk about how to find the angle measures. We do that using inverse trigonometric functions, okay? So let's say that I have the square root of x, right? Square root of x equals y, I don't know. And I'm solving for x. I need to get x by itself. I need to undo the square root. What undoes the square root? Squaring it, because squaring and square root are inverses of each other. The reason when you're solving things, if you have plus 3, you subtract 3 from both sides is because addition and subtraction are inverses of each other. Does that make sense to you? I do not divide by the square root sign. Would that make any sense at all? No, because the square root's an operation, right? So we do the inverse operation, which would be squaring both sides. So when we have something like the sine of theta equals x, and I am trying to get theta by itself, I don't get to divide by side because that makes no sense. It's like dividing by a square root symbol, right? Plus, because this is an operation on a value, you have to do the inverse function. And the inverse function for sine is sine inverse. So I take the sine inverse of both sides. So just like the square root of x squared would just give me x, the sine inverse of the sine of something just gives me that something. It's like I took the sine, and then I undid it. I'm right back where I started from. And that would equal the sine inverse of x. It looks like sine to the negative 1 power. That's not what it is. That's the notation for inverse. It's also the notation for negative 1 power, but you got to know when it's different. Okay? Everybody good with that? That makes sense? Okay, because the concept shouldn't be brand new. Just want to make sure that you understand what's happening here. So it says, if sine of theta equals x, then theta equals the sine inverse of x, or theta also equals the arc sine of x. So inverse sine and arc sine are the same thing. It's a tomato kind of thing. You may not have ever been told about arc sine. We're really going to use the inverse notation for the most part, not saying that this won't pop up, but this does pop up in your higher level maths and sciences, like in calculus. We're kind of using both when we talk about it, but just know that it's the same thing. It's not like a different whatever. All right, so then if we have cosine of theta, that means that theta equals the sine inverse. Oh, no, not the sine. That would make no sense. Cosine inverse of x. So then theta could also equal the arc cosine of x. And for tangent, theta would equal the tangent inverse of x, or theta equals the arc tangent of x. Okay. All right, so let's talk a little bit more about the inverse and the negative 1 power thing, all right? Just so that you understand the difference. If I have 2 to the negative 1 power, what is that? What's 2 to the negative 1 half? 1/2. 1/2. That means we take the reciprocal, right? Negative 1 power means we take the reciprocal. Because of that, sometimes people confuse sine inverse and cosecant. Cosecant is not the inverse of sine. Cosecant is the reciprocal of sine. Sine inverse is its inverse. Do you see the difference? Because I don't want you to get the two things mixed up. They're two completely different things. This, again, if I actually had sine to the negative 1 power, it would look like this. Sine of theta to the negative 1 power. That's what sine to the negative 1 power looks like. That gives you 1 over the sine of theta, and that's what gives you cosecant of theta. This has nothing to do with the inverse, okay? Two completely different operations. Also, I'm sure you've noticed on the calculator, we don't have a secant, cosecant, and cotangent button, but we don't need them because they're all done with ratios, right? And if we have the opposite and hypotenuse, we can choose whether we put hypotenuse over opposite or opposite over hypotenuse, and so we could just take the reciprocal and do it that way, okay? Does that make sense? We all good so far? All right, because again, I know that the inverse is not new to you, but I want to make sure the concept itself makes a little bit of sense to you. All right, so let's look at here. Now, sometimes when you're looking for an angle, you have all three sides. And if so, you only need two of them, you just pick two. It makes absolutely no difference which two. You would use different operations depending on which ones you picked, but you should get the same answer if you do it right. All right, so here's my angle. I only have two to choose from. I know that this side is the opposite side. This is the hypotenuse. This is adjacent. So which trig function am I using? Cosine. Now remember, we always take the cosine of an angle, which is theta. So it's the cosine of theta that equals the adjacent, which is 18, over the hypotenuse, which is 23. Now, 18 over 23 does not reduce, but even if it did, I would not reduce it, because I'm about to use the calculator. Let the calculator do everything, okay? You don't want to make a mistake because you thought, oh, I can reduce that, and you accidentally reduce wrong. Like, there's no purpose in that. It wastes time, wastes brain cells. Just don't do it, okay? Now, we don't have to write the step where we actually show the inverse of both sides. The next step is, I know I have to take the cosine inverse to get it away from this, so I end up with theta equals the cosine inverse of 18 over 23. Then we can type that in the calculator. How are we going to get to the inverse keys? Shift, because they're gold on top of it. So you do just shift cosine. And for this one and this one only, we're going to write down everything the calculator gives us. And I'm going to tell you why. So this gives me 38.49995041. Because I want to talk about rounding. Because I've heard some crazy things in my years that people swear they were taught that way. And Lord, I hope they were wrong. All right, so 3 decimal places puts me right here. So we know, to know how to round, I would look at this one. It's greater than 5. That rounds this to 10, which rounds this to 10, which rounds this to 5. Does that round this to 9, and then this to 4? Heck no. That's like domino rounding. Makes no sense. I've had quite a few students sprinkle it over the years that swear that's how they do it and swear that's how they were taught, hoping they were wrong, and they just didn't understand. So when we do that, because this becomes 0, 0, 5, we get theta equals 38.500. So let's talk about that. That right there tells me we rounded and there's more stuff out there. Even though it says to the nearest thousandth, if you were to push the buttons on the calculator and the calculator spits out exactly 38.5, you write down 38.5. Does that make sense? 38.5 is different than 38.500. They mean different things even though they technically have the same value. Does that make sense to you? Okay, just making sure we got that. And this time I do know what units to put on here. What units would I use? Degrees, because theta is an angle, right? So I have degrees here. What questions you got? Now again, you do not have to write this down every time. I just wanted to visually for you to see that. So you can always just jump right to here. Okay? Any questions? You do number 6. Any questions at all? So we've done some questions where they specifically asked us for sides and some questions where they specifically asked us for angles. These next ones say solve each triangle. If you were told to solve a triangle, that means you have to make sure that you can tell all 3 side lengths and all 3 angles. So any of that you don't know, that's what we got to do, okay? So let's look at number 7. I have two sides I have to find and one angle. Which one of those three things could I do even without a calculator if I had to? Easily. The angle, okay? How could I find angle B pretty easily? What you got, Max? Very good. So I could add 90 and 72, subtract from 180, right? Which is the right answer. Absolutely nothing wrong with it. That's always what I get and what I expect to get. And again, 100% not wrong. Let's just talk about a different way that might be easier. Not that that's that hard. What else could I do besides that? Okay. And well, we could do trig, but we don't have to. But that's easily without a calculator. I know. No, it's not a trick question. Okay, but I just want you to think about this because it's if you again understanding the concept and what you have in front of you can simplify your life sometimes. This is a right triangle, right? We know that there's 180 degrees in a triangle. If this is 90, then don't these two have to add to give you 90? So then I could just do 90 minus 72. Now, we have a calculator, so either way is fine, but if I didn't have a calculator, wouldn't 90 minus 72 maybe be less room for error, right? Do I expect that you can do 90 minus 72 without a calculator? 100%. Is this a calculator question? Yes. Then use the freaking calculator. Do 90 minus 72, even if you know what it is, so you don't have a brain fart and get a very easy question wrong. You with me on that? Because again, it's a tool. This is a calculator question. No shame in using it. Just to double check yourself, we get 18 degrees. Now, I could use angle B to help me find my side lengths, but what if I did have a brain fart and 18 is not the right number? Then I'm guaranteed to get the other ones wrong, right? So the safest thing to always do is use what's given to you. Sometimes you have to use what you found, but if not, use what they gave you so you're not risking anything, basically. Okay, so that means, let's see, BC, we don't have to do them in order, but BC comes first, so we'll find that first. Let's label our triangle. This is 72, that's my angle, so this is the opposite side. That makes this the adjacent side. So that means I'm using what? Tangent. So I'm going to have the tangent of 72 equals the opposite, which is the length of BC. I don't like to use O because I'm afraid I myself is going to use it as a 0, over 15. So that means that 15 times the tangent of 72 is equal to BC, the length of BC. And I want you typing the numbers in and just double checking yourself with me because I want to make sure that you can actually round correctly and we're not having any confusion there and you're not pushing the wrong buttons or in the wrong mode or something. All right, so I have the length of BC now. I could use the length of BC to help me find AB a couple of different ways. I could use it and do trig with it. Could I also use Pythagorean theorem? Yes, but here's what I can't do. If I'm going to do those things, I am not typing 46.165 back in the calculator. You never type a rounded number back in the calculator. You'd have to use the stored value or manipulate the calculator where it's using what's actually in there, which is way more trouble than it's worth when I don't have to do it, right? So just be very careful, because if I literally use 46.165, your answer is going to be wrong. It may be really close, but it's going to be wrong, okay? So no need to use it, so we're not going to. We will relabel, so this is the opposite side, which I don't need that anymore. This is the adjacent, this is the hypotenuse, which means I'm using what? Cosine. So I've got the cosine of 72. That's equal to the adjacent, which is 15, over the hypotenuse, which is the length of AB. So here are my variables in the denominator, which means I'm still going to have a fraction. These two things just switch places. So the length of AB is 15 over the cosine of 72. And then we're going to talk about reasonableness of an answer, okay? Because that's a very important thing. Yes, when we get calculators, not only do you go calculator happy, but you take what the calculator says as gospel. It's only as correct as what you typed in, right? So if you accidentally hit the wrong button or you did it wrong, it's not giving you the right stuff, right? But you go, ooh, calculator gave me this, must be the right answer. But we want to think about reasonableness of an answer. I'm going to give you an example. This has been years now, but it's still my favorite example. When I taught geometry, we were doing, it was a proportional thing. And it was some word problem about the Titanic and the height of the Titanic. And the most common answer made the most common wrong answer was 9 feet, like if they did something wrong. And all these people boxed 9 feet. They were so happy, and I was like, okay, let's just think. Even if you never saw the movie or you don't know what the Titanic is, you do know it's a ship that was in the water, not like a boat in your bathtub. So let's think about 9 feet. Is that as high as this ship is that held all these people? And they're like, no, that makes no sense. Then why did you box it with such pride? Like, clearly something was wrong. Maybe you still don't know what to do, but at least maybe we should go back and find our mistake, right? So let's look at these numbers, because these two numbers are very close to each other, right? 15 is like way far off. So my 3 side lengths are 15, 46, and 48, basically. Do those seem, I mean, they seem, maybe they look off if you think, but do they make sense for our question? If we think about it, which one has to be the longest side? The hypotenuse, and we at least have that, so check. But then these two sides are pretty different, right? But that should make sense because this angle right here is 18 degrees, right? And the smallest side's across from the smallest angle. Since this angle is a lot smaller than this angle, then the side across from it should be a lot smaller than the other one. Make sense? So it's just, make sure you know how to look at a question. And sometimes you will do things where when you get an answer, you really have no gauge to know if it's reasonable or not. And I get that. But if you do, at least think about it for a second. You don't have to overanalyze it for 5 minutes, but just say, hey, does my answer even make sense? You know, do I think that the Titanic is about as high as the ceiling? All right, number 8. So I've got here, I've got 2 side lengths, and I'm sorry, I have 1 side length and 2 angles that I need. So which one can I do without using any trick? The side length, right? I can do the side length because I can use what? Pythagorean theorem. Okay, so let's write this down. 8 has to be c, so I'm going to have 7.6 squared plus the length of JL squared equals 8 squared. So don't be typing anything in the calculator just yet, because we want to learn how to also work smarter and not harder with our calculator. I'm trying to get JL by itself. So JL squared is going to be 8 squared. I know what that is, but I don't care. I'm not writing it down because I don't want to mess it up. Minus 7.6 squared, which means really what I'm looking for, the length of JL, is the square root of 8 squared minus 7.6 squared. Will that square root just knock off those squared signs? And I just have 8 minus 7.6? No, 1000% no. If so, why do we even square them in the first place, right? But now that I have this, type it in the calculator like that, and you're not having to square something, then subtract, and blah, blah, blah. It's all in one step.
It's a great time to take attendance. Also, just a quick reminder, 10th grade students go straight to the auditorium when the bell rings to dismiss you, and everyone else go to homeroom. Continue to have an awesome day.
Okay, so now let's talk about reasonableness of an answer here. Does this seem like, I mean, is it glaringly wrong? Or does it seem like, yes, it could be the right answer? Okay, I mean, it's very different than the other two, but that doesn't necessarily mean that it's wrong. So tell me, and careful with your words here, tell me why you think it makes sense. Or it could make sense anyway. I say careful with your words and nobody wants to speak. I'm going to say it wrong. Okay, here's what you can't say. And I always hear this, but I don't want somebody to be brave enough to speak, and then I'm not trying to make you feel stupid. But you can't say because it's the shortest side. Because before you do it, how do you know it's the shortest side? You don't know. Is that what the picture looks like? Yeah. Sometimes do you have to draw the pictures? Yes. And most of the time when you draw them, do you really know accurately yet? Because you haven't found stuff, right? They're almost never to scale when we draw them, right? And that's fine. So we don't know it's the shortest side. I mean, it looks like it, and if it's the right answer, it's definitely the shortest side, but that's not how we know it's reasonable. The only way I would know, I think at least I'm not glaringly wrong, is that it's less than 8. That's the best we can do right now. Does that make sense? After we get the angles, then we can decide a little bit more, all right? All right, so we can find either angle next. It doesn't matter which one you want to do. Okay? All right, so we'll do K. So here's angle K. This is my opposite side, but I'm not using it because I'd have to use a stored number, and I don't need to, too much work. So instead, this is the hypotenuse, and this is adjacent. So I'm going to have the cosine. I'm just going to use theta instead of k. You could use k, it doesn't matter. Equals the adjacent, which is 7.6, over the hypotenuse, which is 8. Always take the trig, it's always sine, cosine, or tangent of the angle. So that means then theta is the cosine inverse of 7.6 over 8. And type it in because I want that answer in your calculator so I can talk about the next step. To find angle K, angle L, I have a couple of options. I can do trig again, absolutely nothing wrong with that. We just relabel my triangle. Or I can subtract this angle from what? 90. But we do not do 90 minus 18.195. Like, no. In this particular case, you'll end up with the same answer, but it doesn't always happen, so we have to know what to do. Instead, on your calculator, if you have this actual value staring at you, 90 minus, you see the equal sign down there? To the left of it, it says A and S, that's answer. It'll do 90 minus the last answer, just like the 83s and 84s do. And then you hit equals, and we get 51.50. Oh, no. I didn't have that answer. I'm sorry. No, you don't. I didn't actually type that in. I was pushing the buttons, but I didn't type that in. You should get, never mind, 71.805 degrees. Okay. Any questions at all? All right, so now I'm going to take you through a quick tutorial of the Desmos calculator. I'm quite sure you know it's there and you've used it, but I want to show you a couple of things. Okay, if you've never used the Desmos, Delta Math, thank you. If you're already in Delta Math doing your work, here's the Delta Math calculator, right? We can do the trig here. We want to make sure that it is in degree mode. So if you look down here, functions, here's where your sine, cosine, and tangent are, all right? You have degrees and radians. Degrees should be green for it to work. But remember, you can always check yourself. And I want to show you some other things about typing stuff in. So we're going to do the sine, then I have to go back, and I'm going to hit 30. Shh. Notice I haven't hit enter or anything, but even though I finished sine of 30, it gives me my answer over here. It won't save it up there, but now if I needed sine of 31, I could back it up and do the sine of 31. I could back it up and do the sine of 35, and you're not having to retype sine every time and go back. The other thing is, let's say I needed this value, but then I also needed to subtract it like we just did. So I'm going to hit enter. There's my last answer and what I did. But I want to subtract this value here from 1. So I'm going to do 1. I'm hitting it weird. Okay, 1 minus, and then it has an answer key also. And then this is what it would be, so we're not retyping decimals in. Does that make sense? That's how you get the answer above it. Okay. And I know y'all are smart, you can figure those things out. I just wanted to make sure you knew how to get to the trig stuff here so that you could use that. All right? We good? Any questions?